Symbols are critical for technical communication. They are not dependent on any specific language, being international in scope and character. Hydraulic graphic symbols emphasize the function and methods of operation of components. These symbols can be rather simple to draw if we understand their logic and the elementary forms used in symbol design. The elementary forms of symbols are circles, squares, triangles, arcs, arrows, dots, and crosses. Click on each of the following categories to see how these common hydraulic graphic symbols are logically constructed, giving symbolic representation of its component. Lines. Understanding graphic line symbols is critical to proper interpretation of schematics. Continuous lines indicate a working line, pilot supply, return, or electrical line. A dashed line indicates a pilot, drain, purge, or bleed line. Flexible lines indicate a hose, usually connected to a moving part. Lines crossing may use loops at crossovers or be straight across. Lines joining may use a dot at the junction or at right angles. Reservoirs. Reservoirs that are vented are shown as a rectangle with the top line omitted. Pressurized reservoirs are shown as a capsule. Reservoirs may have fluid lines terminating above or below the fluid level. The above oil level return line terminates at or slightly below the upright legs of the tank symbol. The below oil line return line touches the bottom of the tank symbol. A simplified symbol to represent the reservoir minimizes the need to draw a number of lines returning to the reservoir. A number of these in the same circuit will represent a common reservoir. These symbols have the same function as the ground symbol in electric circuits. Rotary devices are shown as a circle. Pumps having an energy triangle pointing to the outside perimeter indicate the energy is leaving the component. A sloping arrow through the circle indicates that the pump is variable or the output flow can be regulated without changing shaft speed. A control symbol with an energy triangle that is connected to an adjustable spring indicates that the pump is pressure compensated. Some types of pumps have internal leakage that is returned to the tank by a case drain. This is indicated with a drain line drawn leaving the circle. Pumps that are bidirectional are shown with two energy flow triangles. The symbol for a flow control valve begins with an upper and lower arc. This would symbolize a fixed orifice. An arrow drawn sloping through the arcs indicate that the orifice is adjustable. This would be the graphic symbol for a needle valve. When we add an arrow to the flow line inside a control box, we have indicated that the valve is pressure compensated or true flow control. A flow control valve with a check valve indicates reverse flow around the valve. Directional control valves. The symbol for a directional control valve have multiple envelopes showing the number of positions the valve may have. A 3-position directional control valve is shown with 3 envelopes. Arrows in each envelope indicate the possible direction of flow while the valve is in that position. The center position in a 3-position directional control valve is designed according to the type of circuit or application. This centered position indicates the flow path of the fluid while the valve is centered. While there are many types of center configurations, the 4 most common are tandem, closed, float, and open. To shift the valve or activate it, we can use a mechanical handle or lever, an electric solenoid, or hydraulic pilot pressure. The springs indicate that the valve is centered when not activated. In position 1 or centered, fluid flows from the pump through the valve to the tank. This is a tandem center. When we shift the valve to position 2, fluid now flows from P to A, extending the cylinder, shifting to position 3, which shows flow now from P to B, and from A to T the cylinder retracts. Pressure valves. The symbol for a pressure valve begins with a single envelope. The arrow in the envelope depicts the direction of flow through the valve. The ports are indicated as 1 and 2 or primary and secondary. Flow through the valve is from the primary to the secondary port. Notice that in the normal position, the arrow is not aligned with the ports. This indicates that the valve is normally closed. All pressure valves are normally closed with the exception of a pressure-reducing valve, which is normally open. The spring located perpendicular to the arrow indicates that the spring force holds the valve closed. An arrow diagonally through the spring indicates that the spring force is adjustable. Pilot pressure opposes spring force. This is indicated by the dotted line running from the primary port perpendicular to the arrow opposite the spring. When the hydraulic pressure piloted from the primary port exceeds the force of the spring, the valve moves to the open position, aligning the primary and secondary ports. Check valves. Check valve symbols are drawn with a small circle inside an open triangle. Free flow is opposite the direction the triangle is pointed. As the circle moves into the triangle, the flow is blocked or checked. Check valves may be piloted to open or to close. Pilot to open is indicated with a pilot line directed to the triangle shown to push the circle away from the seal. Pilot to close is indicated by directing the pilot line to back of the circle or into the seat. Motors. Hydraulic motor graphic symbols are opposite of hydraulic pumps. Their difference being the energy triangle points into the circle indicating fluid energy entering. Two energy triangles pointing in indicate a bidirectional or reversible motor. As with pumps, many hydraulic motor designs have internal leakage. A dotted line leaving the circle indicates a drain line to the tank. Cylinders. Fluid power cylinders with no unusual relationship between the bore and rod size are shown. Single acting, double acting, and double rod. An integral rectangle adjacent to the symbol for the piston indicates a cushion device at the end of the stroke. If the diameter of the rod is larger than usual for the bore size, the symbol must reflect this. Filters. The graphic symbol for a hydraulic fluid condition device is shown with a square standing on end. A dotted line across opposite corners indicates that it is a filter or strainer. Adding a check valve across and parallel to the ports indicate that the filter has a bypass. Heat exchanger. Hydraulic heat exchangers may be considered coolers or heaters. Their graphic symbols are often confused. As with a filter, the base symbol is shown as a square on end. Arrows pointing in indicate the introduction of heat or a heater. Arrows pointing out indicate heat dissipating or a cooler. Arrows pointing in and out would indicate a temperature controller or temperature that is maintained between two predetermined limits.